Okay, for exercise set 2.1, first we're looking at fractions and we're finding what the numerator is. The first fraction is 1 over 3. And the top number, of course, is the numerator. Top number is always the numerator. Bottom number is always the denominator. In the middle, you have a vinculum, but you don't need to remember that part. So number 3 is 2 over 3. 2 over 3. Which one is the numerator? Of course, it's the top number, the 2. And then if we have 127 over 256, which one is the numerator? And of course, it's going to be the 127. After that, we want to note which number is the denominator in each fraction. And there are some new fractions there, but let's just use these. The denominator in 1/3, of course, is 3. The denominator in 2/3, of course, is 3. The denominator of 127 over 256, the denominator is 256. If you have 11 over 12, then the denominator will be 12. The next concept that is presented in our book is the differentiation between proper and improper fractions. An improper fraction is going to be any fraction that the top number, the numerator, is greater than the denominator. A proper fraction is where the numerator is smaller than the denominator. Improper, proper. So what you're going to do in 2.1 is you're going to select out of a set of fractions which ones are improper. Then exercise set 2.2, we're going to discover if numbers are prime or if they are composite. I like to think of prime as primary. They sound a little bit alike. So a prime number would be like a primary number. A prime number is a number that can only be divided evenly by itself, or 1. So 3 would be a prime number because you can only divide into it evenly itself, or 1. What if we had 5? Can we divide any number into 5 other than itself, or 1, and it be an even, come out even? No. What about 6? Well, yes, we can divide 6 by both 2 and 3. 2 times 3 is 6. So 6 is composed, it is a composite number, and it's composed of smaller numbers. Sounds a little bit alike, easy way to think about it. It's a composite number. It's composed of prime numbers, which you could think, okay, primary, as being very small. So let's factor some. This is what's presented next to us in our textbook. Let's factor in 2.2, 12. And is 12 composite or is 12 prime? Well, other numbers will divide into 12 evenly, so it must be composite. We can say 2 can go into 12 evenly, and 6 can go into 12 evenly. 2 times 6 is 12. 2 is a prime number, but 6 is not. 6 is composed of 2 and 3. 2 times 3 is 6. So these prime numbers, 3, 2, and 2, make up 12. 3 times 2 is 6, times 2 is 12. So we have factored 12. We're also given 81, 215, and 15. Can we factor 5 farther or 3 farther? No, so it's just 3 and 5. 3 times 5, 15. $81. 3 times 3 times 3. How about 9 times 9? 9 goes into 81 9 times, or 9 times 9 is 81. But the 9s are not primary, so we need to go one more. 3 times 3 is 9, and 3 times 3 is 9. When we get to the 3s, then they're primary. 3 times 3 times 3 times 3 is the answer. So prime numbers, they can't be broken down into smaller numbers evenly. Composite numbers are composed of other numbers. We can break them down. When they're composite numbers, we can factor them just like we did here. Next, in exercise 2.3, we're going to multiply fractions. 2/3 times 4/5 is our first one. And to multiply fractions, we're going to multiply straight across. Numerator times numerator. Denominator times denominator. And that is how we get our answer for multiplying fractions. Something that might come up, it could be stated as 3/4 times 9. 9 is a whole number. Any whole number can be stated as a fraction by putting that number over 1. So 9/1 is the exact same value as 9 by itself. So we can then now multiply straight across, numerator to numerator and denominator to denominator. Now that's not simplified, but it's multiplied. For now, that's okay. How about 6/7? Times 7/6. And this is the way it's stated. Anything next to a parenthesis is multiply. Unless there's a sign indicating something else, you're going to automatically multiply what's next to a parenthesis. So we know this is 6/7 times 7/6. A fraction is a relationship between the numerator and the denominator. It's a ratio. This would be 6/7 ratio. This would be 7/6 ratio, which is going to matter later on, but it kind of matters right now because if I want to divide out, if I do the exact same thing to the top as what I do to the bottom because of the relationship between the numerator and denominator, then I'm still telling the truth. So 7, I can divide out. 7 goes into 7 once. 7 goes into 7 once. I did the exact same thing, top and bottom. I divided by 7. Nothing that says cancel. Don't even think that word. We're dividing out. 6 divided by 6, 1. 6 divided by 6, 1. So we divided the bottom by 6 and top by 6. We divided the bottom by 7 and the top by 7. So now we've divided out. This makes it very easy. 1 times 1 is 1 and 1 times 1 is 1. So our answer is just 1. Square off that answer, so whoever grades the work will actually find the answer and mark it correct instead of not find it or just mark it incorrect. So multiplication of fractions, straightforward, straight across. What if there are 3 fractions in a row and we're to multiply them? We're going to multiply all 3 fraction numerators and then all of the denominators. Same thing as if we have 2. And I'm making a mess of the board. Okay, that's what it's for. So if we have 1/2, 1/3, and 1/4. 1/2 times 1/3 times 1/4. We're going to do the same that we did with 2 fractions, but we're going to multiply all 3. 1 times 1 times 1 is 1, and 2 times 3 is 6, and 6 times 4 is 24. So our answer is 1/24. We still multiply straight across. Lastly, for chapter 2, we have exercise set 2.4, and this is on page 104, and we're going to be dividing fractions. Well, fractions cannot be divided. Can't do it. But division is the opposite of multiplication. So we can set up our division problem as we're given in the book, 3/4. And we're dividing it by what? 1/5. Since we cannot divide, but we can multiply, and multiplication is the exact opposite of division, we can flip the second fraction and then multiply straight across. So we've made this the opposite. We have 3/4, and then when we change this to 5/1, we can multiply. Now this is saying the same thing this is saying. It's still true. It's still honest, and we multiply straight across. 3 times 5 is 15, and 4 times 1 is 4. So 15/4, or 3 1/4. Nope, 3 3/4. So can't divide fractions. You flip the second one and multiply straight across. And on page 104, you have assigned 2 to 24. Again, there will be some whole numbers put in there. A whole number, like, let's take number 5, 6 divided by 2/3. 6 divided by 2/3. 6 is the same as 6/1. So that's the way the actual problem would be written as a division problem. The 6 is 6/1. You make them both fractions so that you can actually work the problem. 6/1, and then if we flip this, 3/2, now this is multiplication, and we can multiply straight across, and it will be true. 6 times 3 will be 18, and 1 times 2 will be 2, and then 2 goes into 18 9 times, so the answer will be 9. But in actuality, 18/2 is enough for right now. Okay. Basically, that's it for chapter 2. Always remember that you can download a QR code reader on your Android device, or you can just use your iPhone. Hover over the QR codes in your book every few pages, and then Mr. McKeag or Betsy or one of the others will explain these problems to you on your device if you prefer that, or leave a message and I'll be happy to do other problems to explain them more fully anytime.